Exercise 97 is an exercise that involves Newton's first law of motion and Einstein's theory of relativity. It's a little bit long to read, and maybe that's why it looks quite scary. I won't read it all. If you want, you can pause the video and then I'll discuss it more. So in this exercise, we have two graphs that represent the velocity, in theory, of an object, they say a particle, if you push it with a constant force. So if you keep on pushing on something, it's going to go faster and faster, and you keep on pushing even though it's going already quite fast, so it's going to go even faster still. So Newton, according to Newton's theory, the object would just gain in velocity constantly and go up forever. On the other hand, according to Einstein, this would not go on forever. At the beginning, when you push with a constant force, the object is going to get faster and faster, but gradually, when you get closer to the speed of light, it doesn't matter how much you push anymore, there is an asymptote, and you cannot go beyond that asymptote, this famous horizontal asymptote that is the speed of light. Even though you keep on pushing, you can't make the object go faster. Or it's still going faster and faster, but it can't go as fast as you want. It can't go through this asymptote. So in this exercise, all we do is to interpret the limit, what happens as t goes to infinity. So for the first function, the limit as t goes to infinity, positive infinity, of the graph represented by the theory of Newton, what happens is that it goes to positive infinity. Let's check, like if t goes to infinity, n goes to infinity. On the other hand, what happens when t goes to infinity for the function e of t? The limit as t approaches infinity of e of t. In this case, the limit is c. We are approaching y equals c. We're getting infinitely close to the horizontal asymptote. So that's it for the first question. Second question is a true or false statement. We need to decide whether if f prime of x is greater than 0 for all real number x, then f increases without bounds. So it seems that if we have a function such that its derivative is positive for all real numbers, it's just going to go up and up and up until infinity. But is that always true? Can we think of a counterexample? Can we think of a function that is always increasing but doesn't go to positive infinity up here? Can you? Well, in fact, if you haven't found the answer, you can just think back to the exercise we just saw a minute ago, because there was an example there of a function that is always increasing but doesn't go all the way to infinity. It was the function e of t. If there is a horizontal asymptote somewhere, a function may increase but not go to infinity. So e of t in the previous exercise we just saw is a counterexample that allows us to answer no. If we want to, we don't know what e of t is, but if we want to give another example, we can think of a function that looks like that. Y equals arctan of x has horizontal asymptotes at negative pi over 2 and positive pi over 2. So the derivative of arctan of x is a function that is always positive, as can be seen from its derivative. Y prime equals 1 over 1 plus x squared. This is always going to be positive. So that's a counterexample. We can answer this exercise by saying no, false.